For angles on and inside a circle, there's a couple of theorems we're going to deal with. An angle that's on a circle means that it's an angle that has a vertex that's at the edge of the circle, that's on the line of the circle. And then of course an angle inside a circle is one like we talked about before, like an inscribed angle. This angle here, like so, would be an angle inside the circle, whereas this angle right here, that's actually sort of the one that's being described by the black lines, is an angle that's on the circle because it has a vertex that's on the circle, even though the whole thing isn't actually inside the circle itself. When you're dealing with angles that are on a circle, we can use the chord and tangent angle theorem. And the chord and tangent angle theorem basically tells us that the measure of this angle, so in this case DBA, so this sort of outside described angle here, the measure of that angle is always going to be 1/2 of the measure of the arc that it intercepts. So if we know the arc between B and A, let's outline that in, say, green. If we know the measure of this arc between B and A, then we know that this angle DBA is going to be 1/2 of that arc, and vice versa. If we happen to know this angle right here, then we know that the intercepted arc is going to be twice that much. Then the other theorem we're going to use is the Intersecting Chords Angle Theorem. Intersecting Chords Angle Theorem basically says, using the fact that we already know that these two angles here are going to be the same because they're vertical angles, right? If we were to take this chord, the measure of this chord right here, SR, and then add this chord right here, TQ, and then divide the total. So SR plus TQ, and then divide the total by 2, then that would give us the measure of either of these two angles right here. Now obviously they're both going to be the same because they're vertical angles. So SVR or TVQ, either one is fine. We can say SVR or TVQ. Since they're vertical angles, they're going to be the same angle anyway. So basically, as long as we know these two intercepted arcs, we can just find their average to find the measurement of the inside angle. And this angle, by the way, this sort of cross that's found here, this intersect angle, doesn't need to be in the center of the circle anymore. The last rules we had told us what happens when we have a vertex on one side and then they go clear to the opposite side, or what happens when we have an angle that's right in the center of the circle moving out. This vertex here can be anywhere inside the circle. As long as we know the two opposite arcs, then we can calculate both of these angles from that information. And that's it. Let's use that information on our example questions.